This presentation is going to be about rethinking network planning and optimization. So we'll see the major savings that are to be realized, the far from optimal as-is process, the process improvement journey lines must embark on, and how computing power can assist decision making. If you take a typical line of spend, you would see that more than 80% of the costs are actually influenced by the network, with vessel costs, terminal cost, and bunker being the three main ones, and each representing approximately 25%. So line can save costs by having bigger vessels, but by selecting reliable port to create fully utilized rotation with the lowest load cost. It means right-sizing the ship to the trade, so you can maximize utilization. And then the number of vessels you put will determine the speed, therefore the bunker cost. There are a few independent studies that believe that the majority of efficiency gain are in network management of up to 50% compared to other technological or operational efficiency gains, which typically range between 1 to 10%. Slow steaming was also a big thing in order to reduce the cost. Slow steaming is not an operational saving. Slow steaming is a strategic planning decision, and it's based on fuel and vessel cost balance. For instance, if you take voyage optimization tools that are made for ships to arrive just on time, it would save you just a little money, maybe a few $1 million, compared to planning a rotation to run between 16 knots or 20 knots, where the difference might be $100 million. Alliances are network optimization. Alliances aim to increase utilization and reduce costs by filling bigger vessels together. So they pool their volume to optimize the infrastructure with more port call and services, and they offer an improved product with more port pair and frequencies. And it also increased the flexibility to adjust the network to peak, slack, and seasonality, because of course it's much easier when you have 2 sailing in a week to cancel 1, because you have an alternative to offer to customer. However, alliances are not optimal because they're driven by multiple strategic drivers of individual line. If you take the 2M network, you will see some strings are designed for Maersk Line and some for MSC. And the way to know it is just to look at the capacity split between the two for each individual string. Also, network change decision process is likely to be the longer, the more member you have within an alliance. And finally, there are some legal barriers to share the relevant data to design and operate optimally. The P3 Independent Operation Center was a very good idea in order to run and optimize the network. Unfortunately, it was demised by the Chinese authorities. The far from optimal as-is process. Imagine you are a ship owner and you have a couple of $1 billion to spend and 100 plus vessels that you need to deploy on trades, calling ports, offering product to transport box from country to country. How you will deploy those ships to deliver your strategy is what network planning is about. And your strategy is what you optimize your network against. So you need a strategy. Do you want to be market leader to go for volume and market share? Do you want to produce the lowest cost possible network? Do you want to maximize revenue, margin, or profit and be a yield leader? Or do you want to be customer focused and put a lot of the customer requirement in your network? You can basically optimize your network based on all those criteria. Between the lowest cost network and the max profit one, there's likely to be a number of alternatives where you have some customer requirement taken into account. Each trade are likely to be optimized according to their own strategy, depending on the environment, the competition, and the available asset for the trade. So you have some ships, you have the money, so now you just need to deploy them. However, you should consider a few interlink parameter and constraint. Ships come of all size in 3 dimensions, in length, in beam, in draft. They have different capacity, they have different cost. Some are fitted with crane, some are ice class, some have flag requirement. The port, each port is also having unique 3-dimensional restrictions, as well as specific schedule, planning, productivity, tide, cost, and performance. Product have trade specifics and commercial drivers. Box also come in different shapes, in 20, 40, reefer, open top, flat rack, in different revenue. Though the major challenge is actually the weight, as it impacts ship's stability, ability to navigate safely in all weather, and capacity, which is ever changing according to the actual weight distribution on board and the cold draft restrictions. And this is where it becomes a little more tricky. Imagine a plane where the number of seats would change every time you call a new airport. That would likely make the airline industry slightly harder to manage than it is today. The incremental as-is process is suboptimal. It's done once a year on a grand scale basis. It involves countless people that work on a chunk of the network. It involves trade management, operations, stowage, fleet, equipment, capacity. It involves the port themselves, it involves the agencies. The main thing about a network design for liner network is that it must be optimally designed at the strategic level, as it takes a lot of time to redeploy and therefore a lot of cost. It must be right from the first time, because any volume that cannot be handled by a network, there's no quick fix. So it will be more costly, it will be more delay, it will means unhappy customers. So that's another main difference with the airline industry, because they can redeploy overnight and send a plane on the other side of the world to cater for new volume. Most lines build their network incrementally. They cut and pass rotation, and they add new strings to cater for the growth. A line manager will balance assets and market, and then will design a network which appear to be optimal for his trade, based on the actual situation, on the competition, on the port performance, on the available vessels, on the volume, on the revenue, and the profit and loss of the trade. But when you rely on spreadsheets, then you calculate very few options because it takes so much time. And trade are also interconnected. So if you optimize one trade, it might be at the expense of another one or the world. And some costs are also, like commercial driver, are also usually hidden because they're considered as a must. In order to know if it's really a must, then you need to calculate all options and figure out what's the cost of that commercial requirement. The process improvement journey line must embark on. Line needs a strategy and operational competence to deliver that strategy in order to be sustainable. So the scope is actually extremely large. It starts from how you acquire your assets or services, all the way to how you build your network to how you execute your network. So for instance, your own versus TC ratio process, how optimized is it? Which vessel do you go for own vessel type? Which one do you TC? What is your future fleet requirement, your optimal fleet mix? What is the cost and finance for taking the right procurement decision? Also, how you build your network. What is your demand forecast process? How is it done? Most likely empirically, and it's not really evaluated. There's no measurement in place to know how good it is. What is your scaling criteria for the network? What is the port constraint you use? The reliability, the productivity of phasing plan. All the way to execution with uptake management, flow management, coastal scheduling, stowage, contingency handling, of course. There's basically very little measurement in place today, and line have no clue to know how they perform on all those processes. So they need to embark on a new journey and change their mindset in order to try to continuously improve all those processes on a regular basis. Network optimization must be an ongoing process. It shouldn't be done only once a year. And we should start with a blank sheet approach, simulating scenario to take data-driven decisions. One way to do it would be to assess various scenarios to optimize each trade according to its own strategy. And then, once you've done that, then you optimize the whole network by taking a global perspective. There will be changes to forecast, to variable and assumptions, which will call for periodic review. And network planner ought to run scenario continuously in order to optimize the network. We should also put feedback loop in place at all levels to evaluate opportunities and challenges based on real operational and commercial experience. And then on the execution side, then you can optimize the flow continuously to minimize bottleneck and variable cost, and monitoring, evaluating potential contingency options and their cost. How computing power can assist decision making. The whole thing is to automate the scenario simulation in order to prevent messaging big data through a myriad of spreadsheets. So with linear programming, we can optimize a network by calculating all options to find the optimal one based on your criteria, which is either produce the lowest cost possible network or the max revenue profit network, as we saw earlier. The various constraints are taken into account, and you can basically take a set of volume and revenue and float it on all potential network, which are sets of rotations, and calculate all options to determine which one is the optimal one according to your optimization criteria. And by using an iterative process, we can calculate the impact of any variation, whether it's volume, revenue, rotation, vessels, port, or even commercial driver. But as we say, sometimes a video or an image is worth 1,000 words. So I just took a very simple example to try to make you understand how it works, that network optimizer. And if we take the Asia-West Africa trade, there's basically two main ways to serve that trade. Either it's with a direct product with 2,500 TEU vessels, 10 of them going south of the Cape, or you use the Asia-Med network and build a relay product where you transship in the Med and then use 2,500 for them to do the Med to WAF feeder. So what we did is basically we put the same volume and we do a lowest cost optimization purely. And then we will run three scenarios, once where we increase the vessel cost for 2,500 TEU, once where we increase TC cost, and then another one where we increase the bunker cost. And then we ask the tool to tell us which scenario. Is it the relay product or is it the direct product, which is the cheapest? So we start with the first situation, which is the base case. So where we've put our data as they are and we optimize it so with the volume. And then we try to figure out which one is the cheapest. So the base case is actually the direct service with 10 2,500 TEU vessels. Then we increase the vessel cost. So from $20,000 a day, let's say it's now $28,000 per day, and that's the chartering department that told us that's what they could get. And then we re-optimize the network, and then know that's the relay product, which is the cheapest. So we do the same also with the transshipment cost. We increase from $100 per FFE, now we move to $150. And we re-optimize. And in that case, the direct service is, of course, cheaper. And then we do the same for the bunker cost, where we add $350. Now we're going to move it to $500 and rerun the optimization. And in that case, the relay product is going to be the cheapest. So this is where also, if you take the TC, this is where it can also be interesting for terminal operator, because they know that by increasing $100 to $150, that they're out of business for those transshipment volume. And of course, you can apply that to an entire network and change your bunker price and see what's the effect on the network. what is the new optimal network based on this bunker price. This is not what the lines do today. Today, the lines, they make one plan, and then they evaluate what's the cost difference for different bunker price, but not the impact to the network itself. And I have one last thing. It's a longer-term vision, because this is just the first step to use IT in order to help to automate the calculation. We could go all the way to live booking and cargo routing. If you link the flow optimizer to booking system, and for any new booking, you would recalculate the flow live, then you would provide real-time picture of global available capacity and potential routing for fact-based booking acceptance and pricing. So it would improve service delivery, it would remove bottleneck, it would increase utilization, as we could even do slot swap between trade and partners that could be traded live on a need basis. That's it for me for today.